Alright, I'm gonna talk about my development on my fork of Aperant, where I developed its MCP, a bunch more features. I can even go through them. So, of course, I should explain to you what Aperant is. Aperant, former AutoCloud, is an autonomous multi-agent coding framework that plans, builds, and validates software for you. Aperant is good for doing tasks that doesn't need as much. It's not 100% strictly for that, but it's good for tasks that you don't need to pay as much attention. Lots of tasks where you know already what we need, have good specs for. You can run them through here. You can even run them in your absence during the nighttime. There's even an auto shutdown feature I implemented where when all tasks are finished, it auto shutdowns. As Andy has said it himself, the industry itself is moving toward, I mean, not everything. You can always, use VS Code, program that way, use agentic engineering, use your AI agent there, write your code in the VS Code with, or even use Codex or Claude Code, which sometimes I believe might take your attention off the code a little. But I like to have available both ways, either in this Kanban, which I think it's super useful. I reckon there's other ways. I focused a lot on this Kanban board, but yeah, there's also some ways of opening terminals here. I think you can invoke all, I think it's 12 terminals you can invoke at most. I haven't played a lot with this one. Anyway, as you can see, planning queue wasn't in the main version, and I integrated the MCP feature. As you can see, my fork, I focused a lot on the MCP. I implemented it first on main, but then I moved my work to develop. And yeah, as you can see, you can make a task, you set up your agent profile, you can have different models with different thinking/reasoning settings, and you can prepare your description like a spec, task title, etc. You start a task card, they progress through here. You can set like a queue. It's basically when the maximum parallel tasks reach here in progress board, they start waiting on the queue board. AI review, so it's basically in progress board, it plans, it codes, then it goes to AI review, it's validated, it confirms everything, it lines up, and then it ends up in human review. So quick distinction, there is an MCP overview. This includes the internal MCPs. What I made was the Aperant MCP itself, which you could say an external MCP. This MCP is here to work with tools inside in the background. It's basically MCP tooling that Aperant has available inside it. So internal. Sometimes tasks they can bug, and they can usually when they regress to the planning board, it's because they bugged at the start. Either they didn't start planning or they just started it. That's not really common, but it can happen sometimes, and they can regress. And I will go into that just in a bit, which of course it entails my MCP implementation. But yeah, or they can go either bug and they go to human review. That's usually what happens, or they appear with a yellow button with a recovery, and you can recover them by clicking. Okay, so what I developed in my Aperant fork is I thought this setup is pretty good if you want to do a big load of tasks in a framework, and there's lots of benefits of doing all in one framework, and open source even more. So I can go through them later, but yeah, you could use of course lots of terminal windows, but this framework, it starts making a spec, a plan, it codes, and it ensures that it takes the step for the task to complete properly. And if something goes wrong with the framework, it's the framework that goes down. It's not the OS. It's good to have everything narrowed down in one framework. I'm starting to defend already, but I should go first into my MCP implementation and other features I implemented. So there are other MCPs. I found one in LobHub, but it was really bare bones. I developed this one to be more robust. So as I said, these tasks, when they are running through here, they can either fail, either they go to either planning or human review board, or they enter in recovery mode. This MCP work with the MCP tools, of course. I could list them now. There are quite a few. There is MCP tool to associate this project tab to the desktop we're in. I got a script where I can switch around more quickly, but you can associate and switch between them. Tabs will also switch associated with the desktop. There's also this one. It's not MCP tool. You can pin across all desktop. This has an MCP tool. Auto resume has an MCP tool. It means that when the session rate limit restarts, all the tasks will resume, and you can arm this with an MCP tool. RDR system, recover, continue, debugs, resend. I will go through that in a bit. You can activate that with an MCP tool. Associate it to a certain window as an MCP tool too. we can connect an agent. We have an agent here in VS Code to control Aperant. So there's quite some things I implemented. LLM Manager auto restarts. It allows the masters associated to one Aperant project. It enables it restarts Aperant if it needs. Crash recovery. I implemented also an external watchdog. It detects freezes, crashes, and restarts Aperant when that happens. This feature here lets the master LLM, if it detects some problem in the code of Aperant, it's project scope. So if this is on in a project, it can modify Aperant code, build it, close it, and start it again. But without further ado, I have to explain the priority system of the RDR systems. Recover / continue, debug, resend. So when you turn this on, you can, if a task errors, if a task enters in recovery mode, if it goes back to planning, the RDR system will detect this and send a prompt to the master agent with the last logs, the errors, the tasks left, all the information that it needs, so it can rapidly do something about it with the MCP tools. We have a new test button here. Okay, it's sent. As you can see, it's here. Aperant test prompt, and it's sending on the background. So we can set up lots of master LLMs connected to Aperant project tab. Usually it goes like this. Priority 1, it's auto continue. As I said before, tasks usually, if they bug, back into planning board or into human review board. An RDR prompt is sent to the master LLM. So anyway, back to the priority system. So it uses the auto continue MCP tool. That's a priority 1. It usually does that. Then there is a auto recover MCP tool, which is priority 2. If it goes to priority 1, I'd say even also priority 2 more than 3 times, it can write a detailed fix request, can request changes. We can even do this manually. The master agent can request a change to make the task stop breaking, stop stopping, bugging itself. Priority 4, it's not dependent on the other priorities. Auto fix JSON, corrupted plan files, so it doesn't depend on the other priorities. The master agents can correct JSON, correct any files that are breaking the task's progression. So that's priority 4. Priority 5, if it's a deeper issue than that, it can try to fix that either in the tools that the agents in the task card are working with. It can be varied. It's a root cause investigation, pattern detection needed. Anyway, if it can't fix this with priority 5, it goes to priority 6. Either it deletes the task, recreates it, or changes Aperant code, rebuild it as a last resort. It, of course, can only change if you have that setting I showed you before. But anyway, this is the priority system. This is a skill. So when the master LLM receives an RDR prompt, it comes with this skill. It's basically more stripped down version of the MCP skill. It lets it deal with the Aperant MCP in the RDR case. You might ask yourself, oh, why do we do this? Why don't we make just a script automatically click the recover button when it's in recover mode? At least, listen, if the task entered recovery mode, it's because something wrong happened to it. A script just make it not happen. It's not that simple. It's almost like structural engineering. Having a script automatically press it back into continuing, it's not the way it should work. So to say, you have to let it breathe, you have to let it break, wait a bit, let the master LLM click it back. There's also, you can create batch tasks. With one prompt, you can plan with your master agent, start making a bunch of tasks, and then it starts all of them. Or you can tell them to make a daisy chain starting, and when it makes one, it starts. This is usually if you want to work with pipelines. If the agent is always working on the task, it receives a bunch of requests, it makes one, you want it to start it, so you don't waste time. And before you know it, when you come back here, perhaps a problem that was a problem just now is already done or partially done, and that's good. And of course, you can improve this and make all setups you need. The next step would be adding like a Raspberry Pi or some method of turning your server or your computer on automatically when something is needed to be done in the pipeline.